folks out there can see my screen. Okay. So yeah, I'm going to take you on a bit of a different journey into the world of academia and research. We do, of course, work with government, but we're coming from a bit of a different place, I think, in terms of what we do and how we're resourced and so on. So I'm here at Carleton, as was mentioned, and I run a center called the Geomatics and Cartographic Research Center. Chantel's one of our students and colleagues here. But we both belong to a group called the Canadian Polar Data Consortium. So I'm going to tell you a bit about the history there. And that is a group. Sorry, I'm just going to see if this works here. There we go. That formed about 11 years ago now. And it formed because many of us were working in this space at our own universities. We were working on projects together and realizing that we didn't have all the stuff we've been hearing about, fair data and so on, but we wanted to get there. And we realized that we would be much better to do that together rather than just competing individually and trying to do it on our own. So in 2015, a group of universities came together, as well as some other partners, corporate partners. Inuit Tapiriit Kanatami, for those of you not in Canada, is the national Inuit organization. So it's essentially their governance body, and some other different corporations and so on. And so we started out simply by writing proposals together. And we didn't succeed the first time, but we did the second time. So we got a major Canada Foundation for Innovation grant for about $5 million over 3 years to get us started. And we also brought on a number of international partners as well. So there are groups within the global community that, like ISO and other types of groups, try and work together to think about things like international coordination around science. So the International Arctic Science Committee, or IASC, for example. There's another group called SAON, the Sustaining Arctic Observing Networks Program. Arctic Council is more the political entity that thinks about the Arctic as a whole and all the federal governments and so on, not only just the circum-Arctic, but also other countries, China, Japan, Germany. Actually, Germany is one of the largest funders of Arctic research, if you can believe it, and they're not a circumpolar nation. So we brought together, and at the time we were called the Canadian Consortium for Arctic Data Interoperability. And I'm going to sort of tell you a little bit about how that changed, but we were really initially just focused on that idea of how do we become interoperable. And most, not all of those centers that I showed you on the last slide, the universities, have data centers. So there's a major one called the Polar Data Catalog out of University of Waterloo. Laval University has a major data center, and so on. And so they realized they were stewarding these data, but not necessarily sharing them in an ideal way. So fast forward to the end of 2024, we were working really well together, and we were starting to bring on new partners and new people who are interested in the same effort to make data interoperable and to share it, and recognizing the value of standards in that. So we had groups, I'm not listing them on the screen, but groups like the Arctic Research Foundation, which is a major foundation started by a gentleman named sorry, not Jeff Bezos, the guy who started Research in Motion, Jim Basili, out of University of Waterloo. And so they do a lot of data collection. They have their own ships and so on. And again, they're saying, hey, we got all this data. What are we going to do with it? How are we going to share it? And so Ocean Networks Canada, it's a massive cabled observatory system. Same thing, is they're saying, we have it, we're curating ourselves, but we're not bringing it together. So we actually incorporated, so we're now a not-for-profit organization incorporated in Canada, and we have members and a board of directors and so on, and we're starting to pursue resources under that umbrella rather than our individual organization. So for us, that's a really big step, because it's taking us away from this idea that, one university or the other has to lead proposals and things like that. And I think it's helping us to move forward. Our ultimate goal in the sort of medium to near term is to also have a secretariat. We're looking at virtual, But we want to do that because we realize to do the standardization and all that, it has to be sustained. This idea of doing 2 or 3 year grants and having a 2 year gap and so on just isn't going to work. So in our work, we're not this monolithic entity. So the Arctic science is not a discipline. It is defined, of course, geographically. So we have everything from political scientists to anthropologists to CI scientists, indigenous knowledge holders, et cetera, working in our community. So we have to consider many different things when we're thinking about standardization, which is why we don't strictly think about geographic data standards. We're thinking about all kinds of different standards. And again, ranging from social science data to thinking about video standards, because we have lots of people who are doing qualitative research, et cetera. So this slide here just shows you some of the different types of things that we're doing. Some of it is very familiar to you. OGC, we talked about W3C today, ISO, of course, and then we have other entities that we're working with on the development of the standards or implementation of the standards. One of the things that's really central to our work now, 15 years ago, you probably wouldn't have heard much about this. It's the space I work mostly in, which is Indigenous data and Indigenous data sovereignty. So we heard about this earlier. I think Alan actually mentioned about the sovereignty from a national perspective. These are from Indigenous nations, and they're saying, hey, we have a whole history of having data, in some cases, work against us, even in very terrible ways. And so we want to make sure that the data collected by us and about us are in some way governed by us as well. So you've already heard about the CARE principles. There's also ones in Canada called OCAP, ownership, control, access, and possession, and so on. The challenge is, though, is these are principles. These are not code. So the challenge now is how do you actually implement that? And that's much of what we do at our research center. We think about things like local context came up as well. That's a global initiative, but they actually have JSON definitions, they have API definitions and so on. So we're getting to a point where we can say, this is how you do it. If you want to at least broadcast the data sovereignty components and also possibly use it to manage. We have a fairly complicated distributed architecture. So we're not a central data repository. We are a group of different repositories. And of course, this community is very familiar with that idea. It's come up already this morning many times. So we have groups who are in some cases just hosting catalogs, other groups that are hosting catalogs and data, et cetera. And so we basically have a 3-tier system where we have the bottom tier is kind of our data infrastructure. And we have different partners who are publishing their metadata, their data. Where CPDC comes in is this mediation layer, this middle level, because what we're trying to do is say, okay, you're contributing all these things, but for the end user, they don't want to have to go to each of those individually. They want them integrated. So we did some initial work using all kinds of different technologies and so on, and integrated those data and then started pushing them out as integrated layers of data. So that's for the entire Arctic rather than saying, the Russian, the Canadian, and so on and so forth. And that then serves a number of different applications at the user front end. So our problem is that we have complexity. We have a lot of complexity because of all the things I've mentioned, all kinds of distributed, we've got multidisciplinary, we've got indigenous communities, et cetera. And we know that because we also have a project that we started about 12 years ago called Mapping the Polar Data Ecosystem. So that's where I was leading a meeting, and the funding manager I had, or the funding manager from National Science Foundation, I was working out of the US then, said, well, you probably just need to get your 10 or 12 data repositories together and figure all this stuff out, right? Here's a small workshop, figure it out. So we got there and said, well, okay, we have 10 or 12 people here, but let's start thinking about who else we need to have at the table. So a year later, we had 270 organizations who are actually hosting Arctic data. And in fact, my program manager then, who's moved on from NSF, started using this to engage with their funding planning, because they said, this is not the problem we thought it had. So this is actually online. You can go there and you can look around and say, hey, okay, here is the ecosystem and so on. So we have this complexity, but we have these problems. And one of them is that we have things like sporadic funding, I mentioned, 2 years, 3 years at a time. We have limited resources. So yeah, we might have a lot of that, but they're usually relatively small pots of money, at least relative to the task at hand of establishing data infrastructure. We have some hubs that have larger funds. I'm not aware of any that have what we call A-based funding or long-term funding that's permanent. Every single organization that we work with is soft funded by proposals. And so that is challenging, and it's also very precarious because we could have entire data centers just disappear because they don't sustain their funding. So these are the things that we're trying to also solve by sharing data, by getting standardization, so you can have that duplication, replication, things like that, so that we wouldn't have a catastrophic failure. So to do this, years ago, when I started in this, probably in 2003, I think was my first meeting where I went and started talking about polar data standards to a group called the Polar Data Polar Commission, Canadian Polar Commission. And at that time, they said, we'll just get everyone on the same standard and then we're good. So we tried that for a few years. And unfortunately, it didn't work very well. And part of it is because of the diversity in the community. So we weren't just going to mapping folks and saying, you know, implement these standards. We had all these different things. And even if it was mapping data, they're still saying, hey, we're working in oceanography. And so we're working at a MATLAB and doing this and that. We don't know what the OGC is, and we're not going to adopt your standards or ISO and so on. So what we started doing is saying,
example, some of the work that we're doing through the meditation.
oh, I'm sorry, I didn't realize this had that. Okay, that's my colleague Rebecca who put this slide together initially. So what we realized is that with our data centers as well, even if they said we want to standardize, if you have a soft-funded organization, you say you now have to refactor your whole database or your data structures and schemas, where's the $500,000 to do that? We've been running for 15 years and we can't afford to do that. So what we did is we said, okay, we're going to get together. We had a series of workshops and we created using ISO 19115 as the canonical reference and said, we will map everything to that. And what all you have to do is publish whatever you have in your database, and we will then crosswalk it from yours to the other. We heard about that this morning. We also realized that all of a sudden Google was in the mix and people were talking about schema.org. Okay, we need that, and so on. So what we did is we developed these crosswalks, and initially they were just a Google spreadsheet. And then we started turning it into software. We also realized there's a lot of ISO 19115 XML out there. So we supported JSON LD, which is a form of graph data, and XML, ISO, etc. We would bring that in from the different sources in their original nomenclature, their original schemas, and then we would convert it into what's called a graph. It's just a database structure that's a bit easier to work with for this kind of thing compared to a tabular structure. And we also, did it from different feeds, whether it be JSON LD, but also XML, and put it all into a type of database called a triple store. You can then query that, you can transform data, etc. And then we push that into an API. So this CCADI or CPDC API now has all those different data centers I showed on the first slide coming in, and they're normalized into the same structure, whether that be ISO, whether that be schema.org, and so on. Now, that for us was a huge achievement, because suddenly, if you think about you're a user in Canada, you can now go to one source and say, I've got all the metadata from all these different repositories. But the real achievement for us is taking it, sorry, that's just like a API code slide, is to the Polar Data Search, which is international. So that then takes our Canadian feed, it pushes it up using the same kind of approach, and suddenly we're connected to 50 plus through Data One network in the US, we're with Europeans and so on. So people can now go and say, I'm just going to search for polar data, and it's kind of like Google Data Search or whatever, or an integrated catalog. So that for us was a big win. It took a while because we actually drafted the objectives or the requirements for this at a meeting in Cambridge in 2006, before the last International Polar Year, and said we need what we called then the Union Catalog. So I and some others were there. We're there now. And so that's a lot of, because of standardization, but it's the mediation that really made it happen, because we could not get there with our community to full standardization. So Metadata is one thing, data is another. In some cases, the standards approach works where you have a small enough group that it's sort of monolithic enough. So we have weather stations that are not part of the federal system that many different organizations, universities have out there on the land, and they're collecting data, but it's not showing up anywhere in our system. So that's not ideal for, climate modeling and so on. But it's very, very similar data. So we were able in this case to say everybody's going to use a standard called NetCDF-CF, Climate and Forecasting Conventions. That's the one that most of them were already familiar with. We aggregated a bunch of stuff in this system called MODAT. MODAT then has an API called DAP or ERDAP, OpenDAP's another term for it. But what we also did was we put a system on top that allows you to then push that out as OGC as well. And I actually found a research paper where somebody said you can't just say OGC or OpenDAP because each community is so entrenched in their systems that they're not going to change from one to the other. So we said, let's do both. So that allows us to serve different applications. So this one is using OGC. It brings the data in. It uses actually a web map service, has sort of a user front end and so on. So again, this mediation from here to there and having the group that was funded by this CFI grant do that work so that the data providers didn't have to do very much to change their data. Another approach, in this case, it's buoy data from oceanographic buoys, had all kinds of data out there. There's decades worth of stuff, but many of them have different data structures and particularly parameter names at the top, right? Because they're getting collected by some things in the 1970s, other things in the 1990s. The firmware changes. The firmware doesn't care about ISO or any other standards. They just change their stuff. And so all these data centers have this stuff and they're like, well, we want to share it, but man, oh man, how many grad students do you need to put that all together? So what we did is we created a crosswalk called ontology using resource description framework. And you can actually put in the logic of the crosswalk in there. And not only can you say this is the same as this, you can say this is almost the same as this. This is broader, this is narrower, and so on. You use terminology like SCOS and so on. And so all of that is our model for the transformation. That is then turned into queries that can transform data and then push it up into, in this case, British Oceanographic Data Center has standards that are widely adopted. So there we go. What we're doing now, and this will be launched this summer, is we've taken this sort of case study and we partnered with a group in Europe under a project called Arctic Passion. And we're now connecting it to a global vocabulary server. So we're bringing Norwegian, German, et cetera. And within, I'd say by end of summer, you'll be able to go and say, hey, if I have this data, what should I, what parameter name should I be using if I want them to be standardized? And we're including the crosswalk logic in there too. So when you go to this catalog, it will actually tell you that the equivalencies, the semantic equivalencies, narrower than, greater than, and so on. So I'll go quickly through these last few slides. I'm probably close to time. So these are general lessons, community building, critically important, communication, and so on. This was something that we really had to push, particularly our funders for, because we would put in a proposal for a data project and they'd say, why are you doing 30% for workshops? Why shouldn't you be building software with that stuff and not just going and jibber jabbering at your meetings? And it's like, no, when you're thinking about standard, I did have a program manager at NSF say, yeah, like you should do 5% for meetings. The rest should be hardware and software only, So I said, no, when we're talking about standardization, it's just as much human as it is technical, which you all know. And so that's something that we've had to really work on in our community. The second is within our community to say, we're thinking about adapting, or improving existing standards wherever possible, because we go to meetings, oh, we need to create some new standards. It's like, no. Look at it, ISO over here, OGC over there. Let's not do that. Let's adopt it. And so we're getting some traction with that now. People are realizing that with very few exceptions, there's already a standard out there that you can use. And then the other thing that was a real challenge is we're talking about international Arctic data, but we are also working 2 weeks ago, I'm in a community in the Arctic, 950 people, and they're actually producing a lot of amazing data through an app called Siku. And it's like, okay, that's great, but that's very different than some of these global research programs. So we have to think about that scale step. With respect to standards, ISO, all of these are great, but they can be hard and challenging for, I don't know if you're familiar with the idea of long tail data, but the idea is, yeah, you have the big remote sensing data. They have $1 billion to manage their data. Labs have like, 10,000 if you're lucky. So for them to say, I'm going to become an expert on 19115, they just don't have the people to do that. So we need to have these mediators in between, these organizations that can help them do that and say, give us what you have, and we'll help you turn that into something standardized so that's not on all of your individual plates or your grad students who might get excited about it, but frankly, they're trying to get their thesis done, not become ISO experts. So one thing I love to get thoughts on here is the crosswalking now is becoming a really sort of top tier data object. It's becoming important, and there are no standards that I know of for the actual crosswalking. So you can put it into something like an ontology, but in terms of saying this is what you would expect to see to pull these things, they tend to be ad hoc. So they're just people's literally CSV files, or there's some sort of thing. So I would love to see a standards process for the crosswalks, because people are duplicating and they're doing it again in different countries and different organizations, and they might be doing it slightly differently. And then you're saying, okay, then you still have this problem. So ways forward, we're taking it also from those very sort of low level systems to applications where we're using it with Indigenous communities, and that kind of mediation transformation is all being done to translate data that you end up seeing on a really cool phone. And they have no idea what's going on in the back end. They just know they get the data that they need. We are working as a community to develop into what's called a data space. And I won't go into the details there, but data spaces have things like control over the sovereignty, control over private data, and so on. So we've developed a proposal, which unfortunately first time around wasn't funded, but hopefully second time around. These are all of our partners. And what we're trying to do now is to say, and these are, our Canadian partners, not the international, and to say, okay, if we want some of our partners to play like the Indigenous organizations, we must consider the sovereignty. It's not going to be all open data. So that's where, if you look up International Data Spaces Association, you'll find it. We have a major initiative that just got submitted, a proposal about a month ago for the satellite to sleds. You'll see 43 partners involved to try and move all of this stuff forward. If we're funded, it would be $24 million over 6 years, and that would take us right to the next International Polar Year. And then we have a workshop coming up in early June at University of Waterloo called the Canadian Polar Data Workshop. It's the 6th in a biannual series. And thank you very much. And I don't know if I was close to time, but hey.
Thank you very much, Peter. There was a huge amount in those couple of slides. But there was a few things that really picked out for me. This idea that you see data spaces as being the way forward, is something that you're actively considering. You're probably following some of the EU data space stuff.
We're in it.
Yeah, you're in that. Yeah, okay. So where do you see the advantage of data spaces for this type of form?
Yeah, so we're about to be announcing funding under what's called Beyond Arctic Passion, which is EU funded. And what we're looking at there is we have partners in there who are coming from like defense and operations, and they're interested in it because of sensitive data. For us in Canada, we're more on the Indigenous side. And what we can do now with our partners is say, hey, we can model this in such a way that, it's not going to get out there, and your sensitive data about your community is not going to show up in the oil company's database if that's not where you want it. And so that was one of the reasons when I showed you the slide, Inuit Circumpolar Council and some of the others are on our proposal, is because they said, yeah, that's what we want.
Okay. So anybody else have any questions? Any questions online?
Yeah. One over here on the left.
Oh, sorry. Yeah, sure.
Oh, yeah, no, thanks for the great presentation. So I think it was mentioned earlier that, so Internet Canada is starting to look at how the Canadian government can improve its geospatial communication. So curious in that context, like, are there particular things from like a policy or technical types of perspectives that the government could, so, in your opinion, be beneficial to help with all the issues?
Absolutely, and I'm going to follow my experience with my decade in the US and what I saw there that seemed to work. It's probably going away now, but they put in policies that require data management plans and that researchers actually do this stuff, but then they funded it. So I had a program manager who actually turned down a proposal because they didn't ask for enough money for data management. 10 years before that, if you asked for more than 2%, they'd say, oh, that's too much for data management to do the science. This one got turned down because they said, oh, they only put 15%, not 30% for data management. So SSHRC, NSERC, CIHR now have a data management policy requirement, or you have to do a data management plan, but I don't see it yet that says, here's where the money is going to be. And I don't think there's a full understanding of what it takes to actually do proper data management in science. So if you could do anything there to help and bring that to light, I think that would make a huge difference.
Anyone else? Oh,
On your ontology, your multilingual ontology. So if I searched in English for water, would it find data sets that were described in French and German and?
It could. So that one that I showed you, the metadata one, was not multilingual, it was multi-schema, if you will, or multi-standard. The one that I showed you with the cool app, it has Inuktitut, Inuinnaqtun, which is a dialect of Inuktitut. And what's really exciting for us, that one is actually linking genomics data to local conservation efforts. That one has 100 new Inuktitut words for genomics concepts that didn't exist beforehand. So it's designed with that in mind, but you need the raw data for that. And one of the challenges, particularly with indigenous languages, there may not even be a word for some of the scientific concepts, or the work hasn't been done. We tried to get an AI model to do Inuktitut automatic translation of transcripts last week, and it just put out gobbledygook. So, so the answer is yes and no. If the data is there, yes. Yeah.
Thanks so much, Peter. And if you want more, you've got an architect on Friday morning, another open session, so I'm sure there'll be a lot more detail. Thank you very much for the detail.